डॉक्टर बाबासाहेब आंबेडकर ओपन यूनिवर्सिटी.
Namaste dear students. I Samta Rathod, working as an assistant professor in School of Computer Science Department at Dr. Babasaheb Ambedkar Open University. Welcome you all from our Chaitanya studio at Dr. Babasaheb Ambedkar Open University. So, in our last session, we have learned about process scheduling, what is a scheduler, what is scheduling, and different types of process scheduling policies and context switching and also interrupt handle. So, today's agenda will be to learn about scheduling criteria and different scheduling algorithm. So, let's start from scheduling criteria. So, different scheduler aim to achieve different goals like minimizing latency, maximizing through output, or maximize process utilization. Some priorities are needed by all systems while some depend on the implementation environment due to the variant in the specific requirement of the various application areas such as well as different operating systems. Some of the common criteria of different scheduler considering a scheduling algorithm are the following. First is fairness, second one is system utilization, third is throughput, fourth is turnaround time, and fifth one is response time. So let's understand. First is fairness. All process should be able to use the CPU fairly, especially comparable processes. Fairness is a way in which scheduler tries to allocate CPU for comparable processes at comparable rate so that equitable access to resources is granted. So next one is system utilization. The CPU as well as IO devices of the system should always be kept busy. Keeping them execute all the time implies more operation performed per second. Third one is throughput. Throughput is the number of tasks completed by a system per time unit. System is required to finish as many processes as possible through the actual number depends upon the length of the processes. The next one is turnaround time. The time gap between the arrival of process to its completion. It is the sum of the periods spent waiting to get into memory, waiting in the ready queue, and executing on the CPU and doing the IO processes. It predicts for how long an average user needs to wait for a response from the system. The next one is response time. Response time is the time elapsed to get the result of submitted command. It is the amount of time it takes from when a request was submitted until the first response is produced, not the output. Next we will understand about scheduling algorithm. In this section, we will discuss different types of scheduling algorithm such as first come first served, which is known as FCFS algorithm. Next one is shortest job first, short form is SJF. Next algorithm is shortest remaining time, and next one is round robin, which is short form of RR algorithm. Next algorithm is priority based algorithm. Next one is, so we will start from first come first serve scheduling algorithm. It is exactly what it sounds like. The processes are attended to in the order in which they arrive in the ready queue, much like a customer lining up at the grocery store. FCFS scheduling is non-preemptive algorithm, meaning once a process is start running, it cannot be stopped until it voluntarily ends the CPU. Typically, when it terminates or performs the IO operation. This method schedules processes in the order they arrive, without considering priority or other factors. In this algorithm, a process are dispatched according to their arrival time. There is one FIFO queue for ready state processes, and FIFO stands for first in first out. When the first process comes to the system, it will be started immediately and run till it finishes all its job to till it needs to. If other jobs have arrived during the execution of the first process, they will be lined up in the ready queue and will get a chance to run sequentially when the first process terminates or blocks. The main advantage of this algorithm is its simplicity to implement. A single linked list needs to be created and where every time the system is free and the front child will be removed from the list, and every time new process is added to the ready state or blocked the process has moved to its ready state, a new node is added at the end of the list. However, FCFS scheduling comes with a severe problem, which is poor waiting and turnaround time for processes. Consider three processes P1, P2 and P3 submitted to the ready queue, and this sequence and assume the processes have burst time. Here burst time means the execution time. So burst time of different processes are 24, 3 and 3 respectively. Processes P1 will run automatically as there is no other process ahead of it in the queue, which makes the waiting time of it 0. Waiting time of P2 is 24 as it goes after P1 has completed, and the waiting time for P3 process will be 27 because P1 run time their execution time. Here in the diagram below, the average waiting time becomes 70, means 0 plus 24 plus 27 divided by 3. The average completion time for the three processes also becomes 27. That means it adds 24 plus 27 plus 30 divided by 3. This shows that processes with long runtime being in the front queue, short jobs get stuck behind and makes the waiting time very long, reducing the performance of these processes. Subtype of scheduling algorithms are also not suitable for interactive systems. Next, we will understand about shortest job first scheduling algorithm. This is another non-preemptive algorithm that handles jobs based on the length of time that the CPU requires to process them. When there are several equally important jobs queued in the ready queue waiting to be started, and the scheduler picks the process with the shortest execution time requirement the first. Moving a short job before a long one decreases the waiting time for short job more than it increases and the waiting time for the longer processes. SGF scheduling prefers IO bound processes because running short CPU burst job, first it gets them done and moves them from out of the way, and it also enables to overlap their IO request. which enhances the efficiency of the CPU. This algorithm is efficient only if it is possible to predict the advanced amount of CPU time required by each job, which is possible for batch environments, but it is difficult for interactive system. If two processes have the same length next CPU burst, if two processes have the same length next CPU burst, the FCFS scheduling is used to break the tie. Consider the previous three processes P1, P2 and P3 with same CPU time and similar sequences. Now, using SGF, P2 will be executed first, allowed by P3 and at last P1 if they are arrived simultaneously. As you can observe in the diagram, waiting time for process P2 has become 0 for P3, reducing the average waiting time for them is 17 to 3, and the average completion time is 13, means 3 plus 6 plus 30 divided by 3 from it comes 27. However, it is worth to note that SGF is optimal only for simultaneously available jobs. So next one, the shortest job first scheduling is a primitive variant of the SGF scheduling algorithm which preempts the currently running job if a newly arriving job has shorter expected CPU burst time. In SRTF, the process with the least left to finish is selected to run. The running process will continue until it finishes or a new process with a shorter remaining time arrives. This way, the process that can finish the fastest is always given the priority. It operates by comparing the time left for completion of running process with the total execution time of a new process. The scheduler immediately stops the running process and gives higher priority to the newly arriving process if and only if its execution time is smaller than remaining completion time of the running one. For an example, consider the following table of arrival time and burst time for three processes P1, P2 and P3. So here we will understand step by step execution. Time 0 to 5 will be allocated to process number P3. P3 runs for 5 minutes or it can be 5 milliseconds. Total time left is 0 milliseconds as it has shortest remaining time left. So next time P2 11 millisecond which will allocate to P1 process. P1 runs for 6 millisecond. Total time will be left is 0 millisecond as it has shortest remaining time left, and in next time 11 to 19 which will be allocated to a P2 process. P2 runs for 8 millisecond and total time left is 0 millisecond as it has shortest remaining time left. So this is the explanation of shortest remaining time scheduling algorithm. So in our next upcoming session we will learn about other algorithms which are round robin scheduling algorithm and priority scheduling algorithm. Thank you for your attention and please subscribe our YouTube channel BAOUGujarat. Thank you.
स्वाध्यायः परमः